looking ahead for this week, today we're going to do 1.6. There will be some notes on some problem solving with some formulas. Tomorrow is our day off. We don't have class tomorrow. Wednesday is registering you for the dual credit part of this. So you will need your Chromebooks on Wednesday. You will also need your NTC ID number and password if you have one. Or if you haven't gotten one yet, you will definitely need your Social Security number, okay? So that you can get registered for the dual credit aspect of this class. We will also, on Wednesday, have Ms. Rabin. She is my contact over at NTC. She's the dual credit advisor for NTC, and so she will be coming in to help us out with the registration process, give her a little spiel on why this is such a great thing. It's another voice other than me. Plus, she brings gifts, so she'll bring some swag for you on Wednesday. So that's why I want her to come in, because then I don't have to go pick up the swag and she can just deliver it. Promote NTC and all that fun stuff. Okay? Oh, I should keep going. Then Thursday we'll review, and Friday of this week is your Unit 1 test. Okay? So test this week, Friday. It'll be a little longer than the quiz, and it will cover everything in Unit 1. Okay? So, now we can go. All right. So, section 1.6 is I broke up into two parts, but I put them all in one section. So the first part is formula work. And formula work is where you take some kind of a formula. Now I literally just made up two formulas for this one. They mean absolutely nothing, but you don't know that. So we could say that the first one is the aerodynamics of a spitball being flung at your math teacher after you didn't do well in the first quiz. Okay? And the second one is the, I don't know, I'm trying to make something up here. The amount of steps that people at the Packer game last night walked, or something. I don't know. We'll make something up, okay? But there's formulas. There's many, many formulas out there in the world. Okay? You probably have known some of them. I mean, you've worked with some of them before. Perimeter of a rectangle is twice the width plus twice the length. Circumference of a circle is pi times diameter, pi d, or 2 pi r. Lots of formulas out there. Okay? What we're going to be doing today is we're going to be taking established formulas, or made up formulas in this case, and we are going to be solving them for a particular element. So for instance, in the first one, I want to solve the formula for the aerodynamics of a spitball. I want to solve that for M. Okay? And we'll say M is the amount of air you got to suck in order to blow up. Something. We'll make something up. Okay? So if I want to solve this one for M, the first thing that I am going to do is I need to get M all by itself on either side. So I'm going to multiply both equations, or both sides, by 3. On the left side, what that gives me is 3 capital P little q. On the right, that gives me m plus n. Now what I can do is I can subtract off n from both sides, and that leaves me with 3 capital P little q minus little n equals m. And I've solved for m because I have m by itself on one side of the equation and everything else on the other side. The downfall with these type of problems is that they're not checkable. Like I can't plug in 3p cubed minus m into that, into the original equation. I mean, I can, and I should get the same thing on both sides, but that could get relatively ugly relatively fast. Okay? It's not like I can, m was 7, and I can put 7 back in the equation. Any questions on that? With that being said, solve that second one for r. First thing that I would do is I would distribute this 8 in there. The other thing that I could do first is I could divide by 8 if I wanted to in all spots. Okay? Either way. So then that's going to give me 3 little p minus 4 little t plus 6 little c is equal to 8p minus 8r. Then I can subtract off 8p. That's going to give me negative 5p minus 4t plus 6. Oops, that should be a c. T twice is going to equal negative 8r. Now I can divide both sides by negative 8. And so I could get one of my equations that I would accept would be negative 5p minus 4t plus 6c all over negative 8 is equal to r. I would accept it as is. Okay. Another way that you could write that, because you might want to make it look cleaner, is you could multiply both top and bottom by negative 1. And then it just looks a little cleaner. But you don't have to. Okay? Either one works. The second part of today is problem solving. And by problem solving, what I mean by that is we've got word problems. And we've done some word problems before. You've probably written these steps down before when we were doing word problems last week. Okay? First thing I do is you got to read it. You got to read the word problem. Okay? So that you know what you're looking for, you know what you need to find, all that fun stuff. Okay? Then in step number 2, normally you're going to make an equation. Okay? But in formula type word problems, there's probably going to be a given formula for you, and you just need to figure out what goes into said formula. Then we can solve, and then step number 4 is we can check it, but really the check is, does my answer make sense? If it's a time, is it positive? If you got like negative 20 hours for an answer, that's probably not going to happen because it's very hard to go back in time. Okay? Also, in step number 4, we want to label the answer. Okay? Now, if it's just straight up formula work, you should start out by writing the formula down as is so that you know which formula you're using. Then replace your known values and then solve. So that's kind of like step number 2 in there, where if you've got a formula to use in that problem, you should write it out so you know what you're doing, then substitute the values in. The more you show, the more you put on paper, the less chance of you making a mistake. The easier it is to see if you're doing it right, the less chance of making a mistake because you're not trying to do so much in your brain. Okay? So let's dive into it. So we're going to use a very simple formula, distance equals rate times time. Okay? How far you travel is dependent upon how fast you're going and how long you travel. Okay? So it says find the missing variable, and this could be a basic type problem that might be on a test or a quiz or in your homework tonight or anything like that. So if we have a D value, we don't have an R value, that's what we're looking for, and we have a T value, we can use distance equals rate times time. So I would start with D equals RT. Then I know that D is 300. I don't know what my R is, but I know that my T is 4. So we get 300 equals R times 4, or simply 300 equals 4R. Then we can solve that by dividing both sides by 4. 300 divided by 4, anyone? 75. Okay, so 75 is my R. What would the label be on that? Miles per hour, because the distance was in miles, the time was in hours, so this is in miles per hour. So my answer here, my rate, would be 75 miles per hour, or 75 mph. Which makes sense, because we went 300 miles, okay? So we have to have a relatively high miles per hour. I'll put some kilometer problems because you guys are smart enough metrics. We're still on the old English system. Try that one. Forgot to mention too, some of these problems might have extra directions, I don't know, instructions, etc. Like this one might also say round this to 3 decimal places when you're doing it. So it said to use distance equals rate times time. His distance was 600 miles. We don't know his rate. His time was 3.5 hours. So this is 600 equals 3.5R. And if I divide both sides by 3.5, I get, you sure? 85? I get, oh, okay, I see what you're saying. Now I done see. I get 171.428571. Right? Okay. But it said round to 3. So that means we are looking at that one, which means we got to go back one. The 5 says we go up or stay. Up. Okay. So this would be, as the final answer here, 171.429 miles per hour. Which makes sense in a race car. Ooh, I like this one. Go for it. Try it out. So, as I said, we should probably think about making ourselves a picture. Yeah? So we are hanging 3 pictures on our wall in your home that is 16 feet wide. The widths of the 3 pictures are 2 feet, 3 feet, and 4 feet. I'm just putting 4 in the middle because it's a bigger picture. Should have been 2 over there. Whatever. That's just they're not 1. Sorry, I didn't draw it all the way up. My fault. Smiling. We want the space between the pictures to be the same. So what do we want? This gap in here. We want this gap in here to be the same as this gap in there. And for the spaces to the left and the right of the group pictures to each be 6 inches more than the space between. So we want this gap here and this gap here to also be the same, but they want them to be 6 inches more than the space. What's the problem with 6 inches? It's not in feet. So can we make 6 inches be in feet? The half of a foot, right? Because there's 12 inches in a foot. So then this gap here would be x plus 1/2. And x plus 1/2. If you wanted to keep it as 6, then you would have to convert all of your measurements into inches. Okay? We can't go x plus 6 there because it's different measurement things, or different measurements, I should say. Okay? So based off of that, can we come up with an equation? Based off of our picture. What about x plus 1/2 plus 2 plus x plus 4 plus x plus 3 plus x plus 1/2 equals 16. Does that work? Why does that work? It's all the parts all the way across the wall, right? Yeah. It's all the parts all the way across the wall. So that works. Okay? So let's make it look nice and prettier. So we've got 1, 2, 3, 4 x's. Half plus 2 is 2.5. Plus 4 is 6.5. Plus 3 is 9.5. Plus 1/2 is 10. Subtract 10. Divide by 4. X equals 3/2. Okay? Remember, x equals 3/2. What is the question asking? What is the question asking in this particular problem? Hey, what do you think the question is? What is the question? The space between the pictures? Okay, so 3/2 would not be the answer is what you're telling me. Right, exactly. 3/2 is not the answer in this one. Because the question is asking, what is the positioning of the pictures, or how should you position the pictures? It's right here. How should you position the pictures? So the answer is not 3/2 feet, or 1 1/2 feet, or 18 inches. It's not the answer. Okay? The answer would be there should be 2 feet on the outsides and 1.5 feet between. Just answering 1 or 3/2 feet there does not answer the question. Okay? Which is why it's important to read the problem. Okay? This week's worksheet is the pink worksheet that I handed out to you. It will also serve as your Unit 1 review. Okay? So you now have enough information to do all of it. And it will be due on Friday, the day of your test.